Okay, good evening. Welcome to
Family Math number 113.
Family Math 113. Okay, so today you had an interesting problem on an old math contest that gave you a little trouble. So I thought we'd talk about it because it's actually kind of a neat problem that has a lot of different surprising analogies. So the question was this: you have 4 pennies right here,
Yep.
3 nickels right over here, and 2 quarters right down here. How many different amounts of money can you make that use at least 1 coin?
Ooh.
Okay,
cool.
makes sense?
Yeah.
Alright, so we're going to do 2 different problems first, and then come back to this problem. Are you ready?
Alright.
Okay, so here's a slightly different problem, or at least a seemingly slightly different problem. How many different divisors does 18 have? So what's one way we could approach this problem?
Well, we can make a chart.
Let's make a chart.
A little divisor
18. What are the divisors of 18?
So there's 1 and 18.
1 and 18.
2 and 9.
2 and 9.
3 and 6.
3 and 6.
Not by 4.
Not by 4.
Not by 5.
by
And
5.
then we're around the corner.
Okay, so how many divisors does it have?
6.
6. And there's one other way we can look at this problem. We can say 18. How do you factor 18 into primes?
18 is 2 times 3 squared.
2 times 3 squared. So if I'm going to have a divisor of 18, I need to either have
A 2.
2 to the 0 or 2 to the first power. And I need to either have a 3 squared, a 3 to the first power, or a 3 to the 0 power. Okay? So how many choices do I have for my 2's?
You have 2 choices.
2 choices. How many choices do I have for my 3's?
3.
And 2 times 3 is?
6.
6.
Cool.
Okay. Now, do you see? This is 2 to the 0 times 3 to the 0.
Yep.
This is 2 to the 1 times 3 to the 0. What is this?
2 to the 1, oh yeah.
It's 3 to the 1 times 2 to the 0.
2 to the 0 times 3 to the 1. What's this?
That's
2 to the 1 times 3 to the 1.
What's this?
2 to the 0 times 3 squared.
And what's this?
2 to the 1 times 3 squared.
Okay, so there we go. So we looked at the number of choices for the 2 and the number of choices we had for the 3, and we found that there were 6. Okay, you ready for the next one?
Yeah.
Okay, so here's the next question. How many different groups of snap cubes can we make?
Ooh.
Okay, so I have 4 yellow snap cubes, 2 red ones,
And 3 orange.
and 3 orange ones. So show me one group of snap cubes, one possible group you could make.
Well,
You can make one. You can make one of each.
you could do that.
Okay, a yellow and a red and no oranges. Okay, you show me one.
You could do red, red. But you could do this.
Ooh, very good. Okay, awesome. Now, how do you think we're going to count the total number of groups of snap cubes we could make?
Well, we could start with the. We could start with the 1 cube blocks, then go into the 2 cube blocks, then 3 cube, then and so on.
Okay, that'd be interesting. If we did the 1 cube blocks, we might have 1 yellow, 1 red, and 1 orange,
Yeah.
for example. Okay, is there any other way we could think about how we could count all the number of different groups of snap cubes?
Well, it's going to be hard to make a chart to count them because
Sure.
we have 3, so we have to do 3
It's
dimensions.
definitely going to be hard to make a chart.
We can't do that.
Yeah,
right now.
so, tough. Is this one kind of a stumper?
Yeah.
All right, let's make a simpler problem.
Okay, so what if we
How
have
about-
one of each?
How about if I have 2 reds and 1 orange? What might we do?
Well, this would be a good This would be a good time to use my idea. So you could make
1.
this,
Okay, that's 1.
this,
That's 2.
this,
That's 3.
or this.
Oh, that's 4. Are there any others?
Then you could make a group of 3.
Yeah. And there's one more you can make.
Just this.
None. Picking none of them. So there's 6.
Cool.
Okay. Can you see any way to see quickly how we could make? Well, it would have to be 6.
3 times 2 is 6.
Where is the 3 and the 2?
The 3 is here, and then you multiply it by 2.
Where's the 3?
Well, it's the number of snap cubes.
Yeah, not quite. We need to say that this is 3 times 2. So what do I have 3 choices of, and what do I have 2 choices of?
Well, you have 3 total snap cubes.
Well, I do have 3 total snap cubes, but that's not where this 3 is going to come from.
Well,
Maybe we should do like, maybe it's like a divisor problem.
Maybe it is like a divisor
Like
problem.
2 cubed times 3 to the 1 or something.
Aha! How many of these groups of 2 cubes can I pick?
You can.
Just here. How many different ways can I pick those cubes?
Well, you could do this.
1,
Or that.
Two.
or 2,
Or none.
or none. I have 0, 1, and 2 choices for this. How many choices is that?
It's 3.
That's
Okay. How many choices do I have for this?
You have 2.
2. Cool.
0 and 1. So it's 3 times 2 that gave us the 6. Now let's go back to this problem. Okay. How many choices do I have here?
Well, let's see. You still have 3 choices.
For that.
For the reds, I can do 0, 1, or 2.
0, 1, or 2. For this, you can do 0, 1, 2, or 3.
Aha.
And then this one's just like 4.
0, 1, 2, 3, and 4.
Okay.
So that's 3 times 4 times 5.
Okay. 3 times 4 times
Which is
5.
12 times 5, which is 60.
60. So there's 60 different arrangements I can make with these, starting with picking none of them to picking all of them.
Cool.
Pretty cool, right?
Yeah.
Yes.
Okay, now let's go to the next problem. Okay, now back to our original problem. We had 4 pennies,
Yep.
3 nickels, and 2 quarters. Okay, how many different amounts of money can I make that use at least 1 coin?
Ooh.
Ooh.
Well, this looks kind of like our snap cube problem.
Yeah, it does kind of look like our snap cube problem.
Except in our snap cube problem, we can do 0 of anything.
Except in our snap cube problem, we could do 0. So in our snap cubes, we could say the yellows represent the pennies, the oranges represent the nickels, and the reds represent.
The quarters.
But you
The
can't
quarters.
have 0 here.
Okay.
So we just subtract 1.
Well, let's see. So how many, ignoring the constraint first, how many can I make?
Well,
60.
you.
Okay, why is it 60?
Because it's the same problem.
Okay, I have 5 choices for the pennies. How many choices do I have for the nickels?
You have 4.
4 choices, because 0, 1, 2, or 3. How many choices do I have for the quarters?
You have 3.
3. Now this is 60, and let's see, there's 2 problems here with this as being the answer. What's one of the problems?
Well, one of the problems is you have to actually have you can't make 0 in
Right.
this problem.
I can't do 0, 0, 0, so I have to subtract 1 to go to 59, because ours picking 0, 0, 0 pennies, 0 nickels, and 0 quarters doesn't work for the problem. Right?
Yeah, but then you have to subtract 0.
Okay, so I have to
1.
subtract that one thing. That was only one choice, 0, 0, 0,
Yeah.
right? So that's why I go from 60 to 59. Okay, now there's one other problem.
Well, you can do all of them.
You can do all of them, yeah. The other problem on this one's a little more subtle. Here we have to make sure that the amount of money is always different in all 59 of these.
Yeah.
Okay, so for example, if I had just this problem here, a much simpler problem. How many different amounts of money can I make, or a seemingly much simpler problem, with 6 pennies and 1 nickel?
Well, the problem here is like all 6 pennies. This has the same value as a nickel and a penny.
Right. Okay, so here there's a lot of overlap in the problems, or 5 pennies has the same value as a nickel. So if I tried to say I have 7 choices for the pennies and 2 choices for the nickels, 0 and 1,
You'd have a
and
lot
14,
of overlap.
I have some overlap, and so I have to double check. So with our original problem with, what was it, 4 pennies, 3 nickels, and 2 quarters,
So we have to check which amounts of.
we do have to check that there's no overlap. And it's actually easy on this one to see that there's no overlap, because the pennies either have 0, 1, 2, or 0, oh, sorry, 1, 2, 3, 4 cents. So you can't make nickels you can't make 5 cents, and with the pennies and nickels you can't make a quarter. So there is actually no overlap here.
Cool.
So you have 59, but all 59, sorry. I thought I was upside down, but then I realized I wasn't upside down, but then I wrote the 6 anyway. So all of those problems are the same, counting the factors, counting the different arrangements of the snap cubes, and counting the coins. But the one difference with the coins is you have to check everything's different. All right, cool?
Yeah, that's cool.
All right, good job, guys. Good job.